Hello. Huh. Okay. Preloads. So, where we left off yesterday, I had encountered a tricky compiler issue that I was unaware of, where you know what I think I'm gonna do? I think I'm ready. I'm gonna switch like Solarize Dark. Color scheme. Color theme. I feel like it's time. Yeah. Yeah. Oh yeah, it was supposed to like switch colors at night, but I don't think I've ever seen that happen. Anyway, I want this because like anytime I do a here doc, it looks like super broken normally, and this looks a little bit less broken. It's at least like legible. All right, why didn't I do this earlier? What a quality of life improvement. Okay, welcome to the new dark mode stream. Okay, so where we left off, trying to play with preloading of records, and it turns out that this syntax that I'd hoped that I could build towards is no good. And that specifically the problem is like applying a preload to a preload in this sort of like mutative series of things approach, which is consistent with some stuff I ran into when I was trying to build like spec stuff. That like this language is just way more static, and like building something up this way through a series of mutations is less supported, is my take. I think that's what's happening here. So I think what I probably need to do is instead of this, like I think what I need to do here is not try to chain together the preload operations, which will sort of like build up one by one this like struct of arbitrary complexity. That seems tough in this tool set. But I have a hunch that if I instead focus on like declaring a like compound preloader of like here in this case describing that will like compose these two preloaders in advance and then apply them both together here, that's maybe the right path. And I feel pretty good that sounds a little bit like how SQLware turned out. That like SQLware and was like impossible when I was thinking of it as like a slowly growing thing. Where you could just like throw them more and more together, and I would like compose strings of the where content as we went in like run directives. But when I was able to like twist my head around and think about it as like, well, we'll just like build up a tree of these and then know the entire structure of the thing when we go to try build the string for it, life got a lot easier. And I have a strong hunch that we're in a similar position now, where like what we really want is like to build up a structure of these like composed relations that we want to preload, or associations that we want to preload, and then have like one call to a preload procedure, which is going to inspect that entire tree and make its choices. That feels about right to me. Cool. So then what does that mean about the syntax? Maybe I'll start. This was like, I think this is a useful exercise for me. Maybe I'll create a new copy of this file though, because this is like a different, I don't know, thoughts or whatever. Oops. Associations thoughts from like what? It was from like the 30th. And then here, I'll pick up on today, which is like July 2nd. Is that right? I don't think I need the Ruby anymore. I'm going to pull that out. We got that stuff documented. Okay. So I think declaring these still feels pretty good to me. But I need to do something here of like, I don't know, just call it compose. And we're going to take user has many recommended to-dos and user has many to-dos of those two. But like we kind of want like this as well. So maybe I want to do like, I don't know, nest preloader. So let's say like preload recommended to-dos and tags is going to be nest preloader. And this might have to be in a run directive. I don't know. Figure that out when we get there. Of user has many to-dos and to-do has many tags. And then preload recommend, or let's call this like, I hate sort of like noun verber patterns, but this is a noun verber. Okay, and this is going to be to do and tags preloader is going to be nest preloader user has many to dos. Oh, this should have been recommended to dos, right? And to do has many tags. Okay. And then we're going to compose these two. Oops. Compose these two. Just call it preloader. And then I feel like what I want to do is call it like preloaded users. Gets preloader dot preload. I guess that's ugly. On users repo dot all somewhere. Alright. And then what does this mean? Oh yeah, I did think about this before. This does look a little bit like that, right? Passing the preloader into all. I don't think that's what I want. Oh, I forgot that I sketched out like a bunch of these. Okay. But I think this seems reasonable. And like if you really wanted to get into it, like you might inline these. So like this is like one way to do it. Maybe I'll like what's like a terser version of this is probably, I don't know. Does it make sense to say compose preloader of this and this? That doesn't feel terrible. And does it make sense then to say like this? I mean, this is kind of gnarly, but not absolutely the worst. This is not terrible. The one real bummer is that because varargs is not really ideal. Like I don't know. I guess I could generate arbitrarily many. Like it'll like we can't just like string these together arbitrarily, right? Like this would be, this syntax is like a bad idea. I mean, maybe I could get like up to 5, and like if you try to do a 6th one, it's like you gotta fall back. But the way that like varargs work in this is like it erases the types, and so I think it would be, because this really does care about types in an important, deep way. I think that would be a non-starter. But I don't know, man. I don't know. That seems like it could totally be okay. This could be okay. This could work. And here it means that like by the time we hit like a proper preload call, we've got all the bits that we need, so we can like compose the types accordingly, not in a like recursive way, but like in a traverse this data structure way. That seems like it's fine. All right, let's try to build compose preloader, huh? Let's get to belongs to and has many. Let's call it just like preloaders. Oops. Okay, so compose preloader. All right, and everything here is gonna have to be super static. It's all got to be locked down. Nothing here in runtime. That seems important. Okay, so left-hand side type, right-hand side type. It's just gonna return some new type. Okay, and like, what does this mean to have two things preloaded? My dog is making a noise. I think I have to go check on her. Dog problems. Be right back, team. Whew. All right, she was fine. She just heard something in the building. Okay. All right, so compose preloader is going to take, like, let's like look at has many and figure out what all we've got here that we might share. So we've got some associate function. We've got a preload function. And that's all. So we're going to need quite a bit more. Let's go with source type destination. Sure. And I don't think we have like a destination name anymore, although maybe it can't hurt. It seems like it won't. Let's start with no destination name, see if we can get around it. Alright, and we certainly need this. But here we can just call this like preloaded is a pointer to destination. I don't know if we want this to be like a pointer. I think we want it to be a destination record. And this destination is going to look a little different for us because the type that we're going to return is going to be like pretty weird. Okay, so let's say we're just going to include quite a bit more here. So we're going to like include, yeah, so we never really like put a stake in the ground about like the type that this preload is actually going to return, but I think we do need to make a decision about its at least like base types here. So let's call like destination type, it's going to be like a struct, which has like a pointer to destination repo dot record. Well, yeah. Yeah? Maybe this works? So... I don't know, let's call this like... So this is like for composing... This seems like, I don't know, maybe this is possible. Okay, so destination is going to be a struct here, and we're going to say we have like a left-hand side. Already running into some problems here, aren't we? Yeah. All right, so what I was thinking is that we could have a left-hand side and a right-hand side, and this is going to be, we're like using both of them, and each of them will be, like this will be left-hand side dot destination, and this will be like right-hand side dot destination. And I was hoping maybe that this would mean, right, so we pass in a couple of has manys, and this destination type is going to be a pointer to this thing that this has many wants to preload on the on the list of records that we're returning. But then if we like nest a few of these composed preloaders, like if we compose twice, then we're going to clobber left-hand side, right-hand side in this inline destination struct type. So I think these names have to be more dynamic. So bummer, right? But maybe this is fine. And it's the kind of thing where I feel like if there are colliding destination names on these, we'll have a problem anyway. So I think basing this on the destination name seems like a good idea. Using this is lhs.destination. Yeah, that sounds pretty good to me. Destination name, so I have to add this to the struct as well. Except we're probably going to need to prefix it to not clobber. Oof. Yeah, that seems maybe like it's okay. Yeah, this is like possible. This is like possible that this might possibly work. Composed right-hand side as well. Okay. Okay. And then we probably need like associate and preload like we have elsewhere, right? I'm just going to take source records, destination records, to some composed preloaded type of S, D, and then I need a source name still, don't I? I feel like these names are going to have to agree, aren't they? Already forgetting semicolons everywhere. Okay. This could work. This could work. There's a chance. Okay, so what are we going to do here? I'm going to compose the left and right hand side. Yeah, right? Yeah. Right? Does this make sense? We're just going to call the associate method once with left-hand side and once with right-hand side. Although I think we have to... We probably have to do our homework first. Yeah, okay, because this is going to new up... Uh-huh. So each of these is going to, like, construct a new array. Which I guess is going to extend... But it's going to extend the type, like, wrong. Yeah? Alright, so we're at a point now where there's going to be, like, quite a few memory allocations. And this is now maybe no longer the correct... type to use here. Actually, I feel pretty good about saying, about like betting that these will converge and that life can get good. Okay, so let's say like associated is gonna get, like we're definitely not just gonna return that. That's not gonna work, so we need to follow a similar pattern here, right? We're gonna need to new up an array of the correct type, which is like, which neither of these two know about the correct type. And it's going to be source records.count and of type composed preloaded with S. And then why is destination records so hard? Oh, because they may have been composed in other preloaded business? Uh-huh. So this is going to be D. Oh yeah, this is pretty weird. Well, because like this destination and this destination are not at all alike. I think starting with associate is hard. Let's like not start there. Let's start with I don't know. This is hard. Let's try preload. Let's try preload. Alright. And this, right, has like a very specified type where S is the source type, and then the destination type. Right, this is the one with an inverse. I don't think we need to worry about inverses yet. Do we even know our destination type? I guess it's gonna be this. I think maybe this is all trying to be too lazy, and maybe too I'm picking the wrong balance of like laziness and eagerness. Right, like here I was able to just sort of skate by and like not really have the full picture when I was declaring types. And I think part of this pattern that I'm working on, I'm gonna need to just know more types, yeah? And I think I'm gonna need to like walk these and like generate appropriate code. Yeah, right, because this I was thinking that like maybe I'm like the cute passing things through, building them out, building layers on top of things. And I think that the whole point of this is like I'm gonna return. I'm gonna be like returning stuff, yeah. Mm-hmm. So like by the time I'm actually like doing a preload, let me try to like build preload here. Um, let's just say like what if we've just got like a I don't know. I guess this is like I still want this to be a type because it seems easier to work with like types as struct constants rather than trying to actually use constant structs because those can't be like generated as easily. Um, I don't know. That type is hard. Um, okay, let's try that. Let's like ditch this for now, and we'll say that like this compose call is just gonna return you like a tree of preloader types all glued together nicely, and that's all. Similar to how like SQLware and doesn't do anything all that hard. It just like oops, like the types just know about args count changing, and it'll glue your args together. But that we actually do we defer. We're gonna like defer generating like the procedures here, similar to how we defer generating an actual like SQL expression from anding two SQLwares together until later when it's easy, right? Like we'll like run it in here, we'll figure it all out, but like we're not gonna worry about that yet. I like this. Okay. Okay. Okay, so what do we need to do here? I think we need to do some, like a little bit of like type arithmetic. But it'll be okay. I think we got this. I think we got this. Okay, so we get a new destination, which is going to be just two fields, the left-hand side and the right-hand side, with their destination names. and this doesn't want to be, this wants to be LHS.destination. And then do the same thing with RHS. Okay. And then we're going to return compose preloaded of... Ooh, we need the LHS and RHS source to be equal. Right? This must be true. And then we can just like pick one. Does this need parens? I don't know. We'll figure it out if the compiler blows up. Okay, so run... Oh, and we need the source name to be equal as well. Okay, great. And then we can just like pick one of those. So insert runs, sprint. Like we'll be using composed blah of type LHS.source. And this composed prefix, I think, will help us. I think we'll be saved. Great. And I'll be using compose destination. Of type destination. And is that going to be a problem? That is. I think what I want to do for this maybe is like join them with like an and. Like something and something. And I'll just do LHS.destination name, RHS.destination name. And this will get kind of bizarre, right? Because if you do like 5 of these, it'll be like something and something and something and something and something. But I think that this will lead to, I don't know, a little tiny bit of like compiler memory usage bloat, but like not a whole lot more. And it's easy to imagine that we might, like if that's a real issue, we can like compute a thing and like hash it. It'll be fine. Okay. Right, like we could like generate just like some alphanumeric thing that's like suitably distinct based on the combination of the 2 destination names, and like who cares? I think it'll be okay. All right, so now the type that we're going to return from here is going to have, it's just going to have, it's just going to be a struct. It's not going to know anything about preloading behavior or anything. So we'll need to do quite a bit more here. All right, so let's get into this. I think we're going to need to at least... Oh, what am I doing? This doesn't even make any sense. Return compose preloaded and like blow some stuff up. I think I need some polymorphism here, but this is not at all what I'm looking for. I think what I'm looking for is to throw this here and say what I have is an LHS and an RHS. And that's all? That's all. Right? And maybe I'll move this in here below the asserts. That'll like feel a little bit better. And maybe I'll even throw this in here? I don't know. This is some wild syntax. Yeah, this doesn't make any sense. This is a weird place to put it. I'm getting confused. Let's try this. Let's see how it goes. Compose preload is a struct. It takes the left and right hand side. You can compose the left and right hand side this way. We'll do a couple of asserts, but really we're just going to return this compound type. Okay. 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 And now what? What am I supposed to do now? Well, so we have these which map to either other composed preloadeds or things which are gonna like have like appropriate types for this. Yeah. All right. Let me do a little like remodeling of other stuff to pave the way for this. Like really, what I think I need is like like, I think that I'm thinking about this chunk in too OO of a way, right? I'm trying to, like, send a message to an object, which is this type, and that's just, like, not what this language is about. So I wonder if I can, like, destructure some of this a bit to make it more procedural, which is, like, probably going to make things easier. Oh, is Jane here? Hi. So I think I need to, like, do some refactoring. And frustratingly, I think that my specs are kind of going to be in the way for this. Because, like, I don't know, I just, like, depend on the specific API. I guess all this is going to work just fine, and it's that here, I think I want to not do, like, this syntax is exactly, hi. This syntax is, like, exactly the part that I think I need to get rid of. I think I need to, like, I think I want to write this as, like, preload, I don't know. It's, like, a small tweak, right? But I want to do, like, this. But that seems just, like, better form, probably, right? Okay, so let's, like, write preload here. And now this is going to be some has many preloaded. Right, it's like, what even is this type now that I can handle? I think it needs, like, what do we put? We need, like, all this business, yeah? And so maybe we just, like, throw all these into constants into our has many type and, like, run with it. And then I think we can then, it'll be, this is going to be hard. This is going to be hard, but maybe it's okay. Maybe it's just okay. Okay, let's try it. So let's say that, like, all we do here is just, like, return a struct of, just, like, all this business, yeah? Wait, I need a second colon here. Just dump all this in, and that's all. We just have this constant struct. It's going to map the repos that we care about, the source and destination names that we care about, the foreign key, the inverse of. Yeah, I don't know. Maybe that's fine. I think we need a polymorphic here. Is like there's a struct with like a bunch of params, but like no content. Let's say, and it's gonna have all these. And that's it. And then we're just gonna return a has many of all these. This is a pretty weird refactor. I'm not entirely sure I understand even what it is that I'm doing, but we certainly need this name so that like when we write a preload, we can tell it like what is the thing here that we care about. Okay, and then records is gonna be of type has many dot. Oh, but this is probably wrong. Yeah, because like preload, yeah, intentionally takes some generic type here. Oh, I don't know, maybe we can lock that down now, right? So this preload isn't going to worry about anyone sneaking in any fancy behavior elsewhere. It's just going to do its thing. It's going to take its source records of some source repo type and just give you back something. I don't know what yet. Okay, it's just going to return... I don't know, can I do an if here? That seems bad. Like, it'd be cool if this language had like a guard expression. Does that exist? No. No. It's just modifies, and modifies are kind of imperfect. They don't work as well as I really wanted. Like, I would hope that, like, I wish that there was, whatever. Okay. I think maybe what we could do, though, is... Let's worry about inverses later. Inverses were, like, the most magic thing that I did. I think I'll have to just get back to it in a bit. Gotta figure out one thing at a time. You know? I don't know. Maybe even, like, here is where I can run the if and figure out if I've got an inverse, then, like, apply it to the type of the destination, etc. You know? We got time. We got places to put things. Okay, let me comment out all this for now because it is not what I'm doing anymore. Boy, that was a lot of code in one big block, isn't it? Okay, so how am I going to preload? Just with this struct. Let me just like grab this. Wow, is the preload really this few lines of code? Okay. Right, and we got to associate. And I think I have a sense of what associate is going to look like now. Wait, no, these both still want to be... Oh, crap. Right, I'm still returning a type here. So I think these still both want to be like this. Yeah, that's going to be a bummer. We'll see. And what does associate look like? It's got source records and destination records. This wants to be like of type like has many dot source repo dot record, and this wants to be like a bracket of that. Bracket of has many dot destination repo dot record. And it's gonna return something. I'm not sure yet. I'm like, my head is spinning right now. I have no idea what it is that I'm doing. I'm trying to refactor this. Let me write down a few pieces of what it is that I'm trying to do to try to have a better, because I'm just like, what in the world? So in order to generically preload, I'm hoping to have a struct that's going to look more like the final struct from this. We're going to compose some preloaders and nest some preloaders. The compose business, I think I want it to be like a struct, which is going to have a user right, which is governed by, like, these preloaders need to agree on the source record type, which is user in both cases, which is fine, has the same name, which is user in both cases, which is fine, so that drives this. And then we're going to be using something like recommended to-dos and to-dos, because we're going to preload this, which has a destination of recommended to-dos, and this, which has a destination of to-dos, which is going to be of type a struct, which itself will be using composed recommended to-dos, which is going to be a pointer, no, which is going to be a struct to recommended to-dos. Which is a array of pointers to to-dos. And then this is going to be composed to-dos, which is going to be an array of to-dos. Okay. And the reason that we're thinking about it this way, or that I'm hoping to think about it this way, is I can have my has many define just that much, or probably that much. And the has many will know its destination name, which is recommended to do's. Okay, and it's like if you wanted to, okay, so this is like a preload on the composed mess. Or like some of the composed mess. And if you wanted to do a preload on just like user has many to-dos, then we would get a struct of user and like, would we just do this? I think that we would still want like this. I think we'd still want this. And like, okay, cool. So this preload that I'm building, its return value wants to be an array of structs like this. So let's go for like has many preloaded. I'm in the wrong spot. Okay, so this has many preloaded I'm gonna need, but I'm gonna pull it down here so I can think about it a little bit more. So what are like the hinges here? We have like the source type and the source name, and we have the destination type and name, which is about the same, yeah? Source type, destination type, source name, destination name. And the one difference here is, yeah, that's all good. Here, we want using, preloaded, which is of type struct that. Okay, but I think doing this polymorphically is a problem because we're going to run into problems in these being rebound in these nested usings. Although maybe not in this case, because we'll only ever be like one level deep. Like we're never gonna like using this. We're only gonna be using that. And maybe that's alright. Okay, but maybe what that means is that here I want to like declare like some like this. I could figure, right? Because like this has many is going to link to repos and it's going to know the type of the records coming out. But what I'm thinking is that like we probably want this struct to not be polymorphic so that we can more easily be preloading, be using it without worrying about collisions. So yeah, destination repo dot record. I don't know if this is even valid syntax. And is this about what I had down here? Or really here's what I cared about? Preloaded, and then struct, destination name, destination type. Yeah, that sounds about right. Okay. So that means that this preloaded is going to just have type we no longer need a destination name. And we'll call this like a single has many preloaded result. I think this is going to be okay. I think this is going to work out. Okay. So preload is going to return an array of those. And these types are going to be governed by has many dot source repo dot record, has many dot destination, and has many dot source name, which all exist. Okay, that sounds possible. I'm gonna just call this like for specificity's sake. Let's call this like preload has many, and maybe I'll just call it even like with inverse or without inverse. And we can get. I think I feel good about getting clever with this. Okay, great. I think we'll statically map this all out when we need to. Okay. Okay. And we'll call this like associate has many. We've got source records. So this is gonna look up. I feel like this is probably about right, yeah. I think we can say like using here, and that'll help. Okay. This is source records. Really, I don't know why I'm not. Oh yeah, it's not constant. Cool. Why am I worrying about this? This is like working well enough. I don't need to worry about memory management right now on top of everything else. Okay, IDs and that with foreign key with 1, foreign key and arg0 source IDs, destination records, destination repo, which I have from this has many, all foreign key in, which I have here, and then I associate the two of them, and then associate has many up here is not implemented. Great. Okay, this is going to return the same thing, right? Okay. And now let me grab the body of associate from up here. And I think this part was pretty easy, right? The types were bananas, but everything else was like pretty straightforward, I want to say. Right, yeah, associate source records is new arrays. Oh, did I like miss the important part in here? Yeah, that's it. Here, this is what I meant to copy. Okay, get this out of here. Alright, this is hard to read. So let's see. This is the new type that I'm returning. Whew. For source record in source record index in here. Great, great, great. Source repo exists. Destination means something else now. Source name. Oh, I think we're good still. Okay, related destination records. We're going to group them up based on whether the foreign keys line up, an array add them, and then associated source records bracket destination name. Awesome. And now it's just that instead of throwing it right on this record, we throw it in a field called preloaded, which is of type destination, which is going to have that destination name, because that is how we designed it. Okay, so that should line up. And now we return the associated source records, and they should have that structure that I was talking about. Okay, now can I just delete all this code? I think so. And then does this actually give us anything? Like, not really, right? I don't think it does. Get out of here. Where do I call has many? This now, I think I don't even need to like run it. I think I can just say like has many this way. Alright, but everything's gonna fall apart now. Because, like... Oh, user repo... Like, that works, but then here, when we, like, preload, we're gonna, like, call this... Like, this is all wrong. I'm just gonna comment out this business for now. I think trying to get this right mid-refactor is not worth it. Okay. I wonder if anything on my screen is even like legible to people watching in this darker color. I feel like maybe slightly bigger would help. Okay, comment out that stuff. Leave that alone. I feel like belongs to is probably gonna call. It doesn't do inverses, right? Do you ever play with inverse of? No. Okay, great. So I bet this breaks, and maybe I'll just like let it break. Oh no, wait, did I have... Oh, this is too tiny. Did I have like unmerged changes before I started? Oh, I did, didn't I? I think it was just that though. Okay. Linux build.j. Great. Indent expected in declaration. Ident. Oh yeah, because now has many is trouble. Because like this has many. Yeah. Man, I don't know. I'm gonna call it like lowercase. What? I don't know what this means. Ident expected in declaration. Not a single clue what that could possibly mean. Maybe we'll just get rid of this using and find things that pull from it. What else do I need? Source name probably comes from here. Foreign key comes from here. I doubt this was it, but I don't know. This syntax is confusing. Oh, did I just like have this twice? That's gotta be known. Right, compile time. And then... What else? What else? What else? Foreign key. Destination repo. Alright, I bet this still falls apart. Preload. Alright, it has many spec. And because I called this something else. I called this preload has many without inverse. Great. Procedure call is missing argument destination records. Associate has many. Has many line 87. Yeah. Gotta pass that around everywhere now. Look how procedural we are. Not a whiff of an object in this code. Preload is not a member of has many. Great. Okay, this is good stuff. The spec that wants to now be... Oops. Let me... Did I... Yeah. Do that. And then did I get this right elsewhere? Yes. Yes. Okay, great. And let me, like, not mess with this stuff. Well, actually, if that spec fails, life is good. Test user is not a member of test to do. Okay, great. I am gonna comment out this block. Just the it. Okay. D has many line 49. Where'd this even come from? What does want to be? Huh. Sounds like a has many dot destination repo dot record. Whoa! The specs pass? Incredible. Did I comment out all of them? Can I print like this actually ran? I'm shocked. What a refactor! Whew. I can't believe that actually worked. Alright, I think I'm not gonna worry about inverses yet. I'm gonna add them to my to-do list here. Inverses with nested. Okay, that seems like a cool thing to get back to later. Okay, wow, this is astonishing to me. Okay, so now I have the stuff that I was talking about over here, yeah? So when I'm returning this preload, this is the structure that I'm getting, and I have a hook into like this little struct type. And so this preloaded, which would clobber or collide, we don't have to include. Okay. This is wild. I'm dizzy with anticipation. Alright, so we have our composed source this, and our left-hand side and right-hand side destination. And our destination is a struct, which just is a... I think this wants to be a couple of usings. Right? Okay. And this destination struct is like not dependent on anything. Alright. You know, I think there's like a chance? I don't think we even need that. I think we're just fine, right? Like, we should be able to just call it user still. That shouldn't collide. Okay. Okay, so how do I preload a composed preloader, huh? What are my source records? It's gonna be composed preloader dot, let's call it LHS dot source. I might be able to like sneak in a modify directive here to do these asserts. I don't know, is that a good idea? I think that's probably a good idea. I don't know, assert LHS. Oh, I don't have type infos. I don't think it's worth it. I'll use this for now. Yeah. Oh my god. Okay, I'm once again dizzy. Okay, so LHS preloaded is gonna be preload has, what did I call it? Preload has many without inverse. On source records, well, on composed preloader dot LHS, composed, no, source records. Right hand side preloaded is going to be preload has many without inverse. Composed. Okay, so we've now done the two queries, one for each preloader. They've glued everything together. And I think I want to return associate composed preloader on composed preloader with source records, left hand side preloaded and right hand side preloaded. I don't know if following this pattern here is going to be really helpful, but I kind of feel like it. Oh, I'm already getting syntax wrong. Okay, so this takes a composed preloader, takes source records, oh, I don't have a capital S source, do I? Yeah. Is that going to be a problem? I hope not. Wait. Okay, I think this is all wrong. I'm going to delete that for now until I get there. Why do I have struct twice here? That seems wrong. This seems about right. How did that work? I don't know. That doesn't make any sense to me at all, but whatever. Alright, so my destination here is going to be... I deleted some of the code that would have been helpful in defining this. Okay, and I think this is the part that I want to pull out and call it... So this wants to be composed preloader. And then that's going to be different from what it returns, which will have much less. And it'll be like that, right? Composed preloaded result is going to be... It's going to just take a source, destination, and a source name. It's going to need a destination name too, isn't it? I'm running into problems here already. Maybe I'll give this like a... Dang, how is this gonna work? What do I want it to look like? I thought this through already. Alright, so... Using recommended to-dos and to-dos. using composed recommended to-dos. Okay. Where do I define the preloaded bit in here? Using a preloaded of destination, which comes from here. And it's okay because we're never going to have nested usings on these because this is like the leaf level. So these are allowed to be polymorphic. But these aren't. This is going to be tough. So like, oh, but like maybe it's actually kind of fine. No, it's not really fine. Right, okay, because I need like a name for this, I think. This is going to have to pop up in like a return type, which means I think it's going to have to be polymorphic. I could like generate this struct's name in the function that I wrote. So this is just like the destination of left-hand side. This is just the destination of right-hand side. This. So if we imagine going one level deeper, another thing and recommended to-dos and to-dos. So like this struct is this like leaf. This struct is a leaf. This struct is a leaf. We're kind of like fine. But now this and this are going to be composed together. And like this one will already need to have been a generic type with like a left-hand side and right-hand side and some business. And this one will also need all that business. So I think that like the type which we return from here cannot take any generic, or no, like it's like the type that we're like inserting into this thing can't take any generics. Like here, right? If we're using something, this destination maybe we're good. Maybe I thought this through, right? And like we're fine. Let's just try. I'm worried. But maybe it's really not so bad. Okay. It seems fine. It seems fine. Maybe it's fine. Right, because like this result, like I bet what happens if we're composing these deeper, I'm gonna run at it. Right, like we pick one of the sources and then we use the destination type, which is going to be just this. And this has no problems, right? And we're calling a using on just this destination. We're not calling a using on this like composed preloaded result. So I think this is okay. And then this wants to be composed something, and this wants to be composed something else. That feels important. Don't want to get that wrong. Okay. I think there's a chance. This will work. Alright, so this returns a composed preloaded result, an array of them of the source is composed preloader dot LHS.source, let's say. The destination is composed preloader dot destination. The source name is like composed. That's just a source name, let's say. And the destination name is composed preloader dot destination name. Okay, and all these constants exist on like the preloader, but they won't, and they'll exist on this result, but they won't be on this destination, and the destination is the part that we're like nesting and like recursively using and stuff. So I have hope that there's like, this is gonna be okay. Okay, we need to duplicate this here. It would be cool if there was some shorthand for like defining a function that returns a type for terse or return values, but wishful thinking for now. Okay, so like results is going to be a new array of size. Like, what does this associate look like? Wait, I don't really need associate in the same way, do I? Let's get rid of this. Okay, we've preloaded the left-hand side, we preloaded the right-hand side. I'm gonna allocate a new array. Of type source of with count source records.count of type this nonsense. It would also be cool if there was some alias for just like return type. Just like figure it out for me. Look at the method. Look at the function. Give me the return type for this procedure call. Okay. Compose results, and then now we want to do. Yeah. Okay. So like for pointer to compose results. Let's go for like left-hand side result is left-hand side preloaded dot it index, and the same for right-hand side. Okay, and now I want to say it. Okay, so now I'm gonna have to like insert print business, right? And I want to say it dot gets left hand side result. Oh, just gets like source record, right? How does this work in associated? Yeah, just set it to the source record. Okay. It dot whatever gets source record. That was easy. Okay, and now I want to do it dot, and here's where I have to do some funny traversal, don't I? Well, but I've got all my usings queued up, so I can probably just like set Like it dot something gets left hand side result dot something with left hand side. Oh wait, what am I even calling here? I need compose preloader dot left hand side dot destination name, right? And then do the same with right hand side. Oh, and I probably have to embed this arg twice because I use it twice. Yeah. This seems wild. This seems too easy. I think I want to free these. I'm not going to worry about memory management yet. That's terrifying. Let's get some tests passing. Okay, how in the world am I possibly going to test this at all? Why don't I just call it preloaders? That should be called, like, composed preloader. That feels better. Okay, I have a composed preloader. Gonna forget about that for now. Actually, maybe I can bring a little bit of this back. And cut to .user. And just comment that out for now. That's inverse related. This is going to be preload has many without inverse on user has many. What did it used to say? And really, like, that's wrong because I'd like to include the inverse. Let's see if anything builds. We got problems, right? I've attempted reference type, but this is not a namespace type. Field was LHS. Huh. Compose pre-later, line 28. 28. Oh my god. How did that possibly build? I never go this long without making mistakes. Oh, do I have my poops still in here? Let me get these poops out of here. And I broke inverses, so... Oh, and I got rid of that stuff anyway. Okay. Alright, do I have multiple has manys on anything? I think a to-do has multiple has manys, doesn't it? Oh, I think I threw away that code. To belongs to user. I think I have a concept of like a tagging. Like tags and stuff. Let's check out the database. Right, I have tags and taggings and stuff in here. Git checkout. I don't know. Multiple preloads experimentation. And I just want repos. And I want tags repo. Alright, what do these look like? Amazing. This is just multiple belongs to, it's not multiple has manys. Well, it's a real disappointment. A real swing and a miss. So what am I going to change here? I could apply the same refactor that I did already to belongs to. That sounds pretty bad though. Do I have an extra has many and I just didn't realize it? Use as many tags. I don't want to build has many through. That seems like a lot of work. What have I got in my schema? I don't know. Maybe like a user creates tags. Let's do that. Is this right? Foreign key. How do I create a constraint? How do I add a foreign key? This is not what I want at all. Okay, whatever. Just give me the code. Give me the code. Create table, constraint. Alter table, add constraint, foreign key, cool. Tags, add constraint. Ugh. Let's get me to alter table docs. Get me to current alter table docs. Foreign key. Great. Add constraint. I need a constraint name. Tags, users, FK. Foreign key. User ID. References. User's ID. Delete. Nullify. Isn't that a thing? Referential action? I'm to put it in quotes or something? Oh, set null. Cool, okay. Great, okay. Update tag set user ID. This one where ID equals 1, Set user equals 2, where user ID is null. Charlie, you're fine. You don't have to bark. Okay, let's select all tags again, make sure we get something. Great. Okay. So now we can say user has many tags and user has many to-dos. Tags repo. I guess it makes sense, right? No inverse of. Okay, and in main.j, I want to do now users with to-dos and tags. Gets preload compose preloader. Preload compose preloader on compose preloader on user has many to-dos, user has many tags. On users repo.all. Great. Okay, and then I want to copy most of this and just do like a little bit more printing. I want to print the tags as well. And now this, there's no way this even compiles, yeah? This is gonna like blow up in a million ways and I'll figure it out. Tags repo. Alright. Okay. Declaration of argument 1 requires a value bake. Expression is not a bakeable literal. Its type is type. Line 95? Oh wow, we're so close. Destination name. Destination name. Ooh. It nothing gets source record. Yep. Oh boy, this got weird. User ID is not a member of tag. Oh, alright. It is now. Now what? Undeclared identifier. Users with to-dos. Right, because I called it this. Wow, we're making it pretty far. LHS. Compose preloader.j15. Right, this is just source name here. LHS using user. This is just source. Wow. This wants to be a pointer, doesn't it? This wants to be a pointer. Whoa! Hey! How? Okay, well, the user didn't really work out. This is not perfect. But check it out, we got tags. The tag made it, the to-dos made it. Look at all this preloading that we did. Wow. Wow. Okay. We composed a couple of preloaders. What a mess I've made here. Alright, so I wonder why the user didn't make it in. That's kind of a bummer, isn't it? And they're both pointing in the wrong spot. You know? Okay, so what happened there? Like presumably we got source record, it dot source name gets a pointer to source record, can't be doing what we want it to do. Source record's an index. The types line up. Why isn't it working? Why am I getting zeros and stuff? Uninitialized user. Because like clearly, I don't know. Like I bet if I just go like LHS result dot, like does that work? No. A.user gets LHS.user, unidentified LHS. Oh yeah, this isn't it. It's LHS result. That time it worked out, yeah? Got some dates, got an email. Yeah, I wonder what broke about this. Like, here, or in this, like, associate business. .user just gets source record. Maybe I just like took too many pointers. I don't know. Is that it? No. Alright, what am I doing in here? For pointer to source record index. And then I'm setting associated source records index to that. Oh, you know what it is? I bet it's because it's like setting it to like to like the no. Yeah. Okay. I want it to be. Let's go with like that. Like we only use source record in like 3 places. Memory management, huh? It can be tricky. Well, we did it. Users with to-dos and tags. We get tags, we get to-dos, we get both, we get a mix. Cool. I think I want to, you know what I want to do is like log round trips to the database real quick. Just to see, right? It's like every time I'm doing a, yeah, this is not right. When I like SQL select execute here, I'm gonna like print it. So we can know like exactly when we hit the database. Which I didn't write any code that would like lazily introduce an n+1. Like that doesn't exist here, and the fact that the types line up is like evidence enough that clearly we're using this preloading. I just want to feel great about the fact that we're doing this how we are. So let's like print SQL select execute on something with prepared SQL. And it's going to run it a lot here because we're running tests and stuff. And then, select ID created at from users. Select some stuff from to-dos where the ID's users in those two. And then select from tags. Man, look at this well-behaving Postgres client. Look at this well-behaved web app foundation, whatever. Huh. I am shocked that this is like doable. Okay, so I can't preload the same thing twice, and I don't have more stuff to work with. So okay, so next is really just make this thing polymorphic, right? This thing's like bolted down. So this is like ish. Okay, so polymorphic preloading. Because right, like if you look at main, we needed to call separately, like preload has a menu without inverse here, and preload compose preloader here, right? Like it'd be cool if we could just call preload, but that's pretty hard because like these are just types, and there's no good way to trigger like, you know, first class static dispatch based on distinguishing between types, because a type is just like, it's opaque, right? There's no way to do clever static dispatch for that. And so like what I did for SQL where, like it's ugly, but I did some of this business where I figure out like, all right, if we're looking at default SQL where, then it's like empty. If we're looking at a SQL where and, then do like a different behavior. And I think we might need to do that. But the good news, so like there's sort of like a trade-off here in terms of like runtime performance. This is really fine, right? Because like these static ifs get blended out, get like pulled out during compilation, and it will be statically linked. But in terms of extensibility, it's a bummer. It means that like if like an end user wants like introduce a new like kind of preloader strategy or a new way to glue preloaders together or whatever, there's not going to be some like duck type that they can mess with. They're going to have to edit our source or whatever. Maybe there's a way I can think of to like introduce a new kind of a hook that they could lean on. We've got the same problem here. Maybe it's the case that this sort of like static lookup table situation is like an abstraction I could pull out, and end users could like extend it, you know, or like per their own. There's like a lot of strategies that I might lean on for that. Yeah. The other thing is that like maybe it's the situation where like we just like embed. I'm finding myself reaching for polymorphism some more again, where like maybe here, if there were just like a message that we send to this where type, right, like this like sort of conditional logic static lookup business is like crummy. And it might be the case that what we really want to do is like define a procedure that lives on SQL where and lives on SQL where and that we could statically dispatch to, and then we'd also get stricter type checking on these things and more composability. Maybe like rethink SQL where two-string polymorphism. Can that be procedure on the where type? Cool. Well, I think I'm about to hit, like, I think I've reached a pretty good break point for the day. I haven't restored has many inverse behavior. I haven't made has manys and belongs to's play nicely together. But I basically did, I do feel pretty good about, like, nailing a version of, like all this stuff that was making my head spin and that still kind of makes my head spin. Right? Like, this, like, works. The only difference is you gotta, like, do some, like, runs. But that's not so bad. Oh, I don't have nests yet. I gotta get there next. Alright, team. I'm gonna check in my code. There's gonna be a lot in here. Where am I? Belongs to spec. Cool. Has many spec. Yeah, comment all that out. Yeah, compose preloader. Build it. Uh-huh. Has many. Delete some code. Refactor some code. Load some new things. Get rid of inverse checking. Add tags and taggings. Great. Compose preloaders. What a session. That was very exciting. As always, it's pushed up to GitHub. Man, what a weird project this is turning into. What an exciting thing, huh? I wonder what my, before I check out, I wonder what my, like, added strings look like these days. We've got this spec runner. Wait, should that still be inserted here? I think W3 is production, right? Okay, yeah. And W4 is tests. Yeah. Cool. We got some SQL parsing. We got taggings. And has many. Love that. Module. Postgres. Yeah, we just got little compose tags, compose to-dos, associated source records. Yep. I want to find to-dos and tags. Hey, this is fun. Huh. I wonder if I should, I wonder if I'm doing myself a little bit of a disservice by, like, it does make these added strings, like, there's an interesting trade-off here with the way that these added strings actually are, like, somewhat valuable as an artifact. Like, this is interesting, right? Like, this looks like enough of a statement that you can figure out, like, oh, cool, so this is, like, parsing a column, and it's got to be one of these things. And, like, it's, like, a whole idea, right, of how do I transform some value from some column, and, like, where do I put the outputs? Whereas, like, these strings, using user source, or even like composed, and like this one I was happy to see, to-dos and tags. Like that, this means nothing, right? This is like totally meaningless. And I wonder, like, would it be better to like print this whole expression, right? Like, would I be helping myself out more if I... Why does this line appear twice? Oh yeah, left hand side and right hand side. What? Oh yeah, because they're different. But like, would I be doing myself... Would I be helping myself more if I like emitted these lines in one insert instead of like seeing them like this, right? Or like, moreover, would I be doing even more good for myself if I like inserted like all of this together? So, oops, all of this together. I don't know. Lots to think about. It's a weird new language with a lot of new vocabulary. Cool. I'm getting offline. Thanks for watching, everybody.